Hey everyone, I just want to talk a little bit more about 7.1. I know I posted the AP Stat Guide video, which is a great intro, but I figured I would complete the homework quiz myself and just post it for you guys to look at because it's a good overview of 7.1. And 7.1 is an intro to sampling distributions, and we talked about that first semester, so this should be a review. And this is where we started getting a little bit confused with normals because the standard deviations would change, but the process really works the same. So the content's not very difficult. It's just really knowing, one, if you're dealing with proportions or means, and then two, if you're given p hats or p, or if you're given mu's or x bars. So the first question here on this homework quiz, this is not an assignment for you. I just want to go through it so you get a little bit of everything. We're asked to decide if in each of these parts, whether the underlying number is a parameter or a statistic. And just to review, parameters are numbers that describe a population versus statistics are numbers that describe a sample. So you collect a bunch of data from a population, you calculate some number, that's a parameter. You take a sample, a subset of a population, you make some calculation, that number is a statistic. So if I read through these parts, I'm in part A, it says nationwide, 84% of people are living in the same house they were living in 1 year ago. The town council of Pleasant Valley surveys 100 residents to find that 75% of them have not moved in the past year. So if I look at these underlying numbers, the first one I see is 84%. That's nationwide. That's a big group of people, right? Nationwide. So I'm going to say that 84%, that's a parameter. Also, same as 0.84. So if you look at this number, a percent, just as we go on forward, percents are proportions. So if you're given a percent about the population, that's really a P. It equals P. So that's a population proportion. Versus if I read on, they take a sample of 100 residents. So right here, 100 residents. And then this is the number they calculate from that sample. So 75%, that's my statistic. We don't really use percents. We're going to make it a decimal. And then this is a p hat. Because it's a sample proportion. It looks like this. Sorry, I can't really draw, but remember from last semester, this is good old p hat. The next one. The mean birth weight of infants in the United States in 2006 was 3.3 kilograms with a standard deviation of 0.57 kilograms. An obstetrician determines that among her own patients, the mean birth weight is 3.6 kilograms. So if I go to my first underlined number, 3.3 kilograms, that was all infants in the United States in 2006. So what it's known to be for the population, well, that's a parameter. And more specifically, that's a mean. I'm just going to write the word mu, but that's a population mean mu. And if you forget the symbol, that's this guy. And then my next number I see is 0.57 kilograms. That's the standard deviation in 2006. So that is also a parameter. So 0.57 is a parameter, but that's sigma. The population standard deviation sigma, and that's this symbol. And then I read on, the last number I see underlined is 3.6 kilograms. Well, that's of this doctor's specific patient, so that's a small subset. Not necessarily has to be the same time period. And that's an X bar. And again, if you forget these symbols, X bar is just an X with a line over top. That's a sample mean. All right, question 2 on the 7.1 homework quiz. Again, not an assignment. Says, suppose you have two different statistics, call them A and B. They can be used to estimate the same population parameter. So just for sake of commonality here, let's just say these statistics are A bar and B bar, so two sample means. And they're both being used to estimate some population mean of mu. Statistic A has lower bias than B. And A also has low variability compared to B. On the two axes below, draw two parallel dot plots showing 8 values of each statistic that are consistent with these characteristics. Assume the parameter value is the arrow on the axes. So this is my mu. This is the true population mean. And when you get to, I think, Friday's assignment, when you're looking at population means, the AP Stat Guide does a great job at explaining how sample means are used to estimate a population mean. But for now, I'm going to go back to something that came up in the book. And I gave you this in the notes first semester. So if you look at this diagram, it talks about bias and variability. And you see these different bullseyes. So in the first bullseye, or let me talk about what variability means versus bias. So variability is spread. So how spread out are those sample means in this case, or how spread out are those statistics? Versus bias, is it measuring what it's supposed to? So is it hitting the bullseye? So each of these targets, the bullseye is what I want to hit. That's the population parameter I want to estimate. So if you look at these examples, so in example A, this bullseye, all of these points are very tightly close together. However, they're missing the target. So this would be a sampling distribution that has high bias but low variability, meaning high bias, it's missing the target, but the points are close together, so it has low variability. In bullseye B, this one, you see the points are very spread out, but they're around the target. So that means it has low bias. So yeah, I'm not all in the target, but I'm around it. And it has high variability because the points are very spread out. In example C, here's my target. And again, you see these points. I want to hit the target, but they're missing it. So that means it has high bias. These points aren't around the center. And they're also very spread. So this is the worst case scenario, having high bias and high variability. And then D, you could have, this is the best case scenario. This is low bias, or really no bias because I'm hitting the target, and low variability. So when I go back to answer question 2 in the homework quiz, it says A has lower bias. That means my little dot plot points on A, this is probably going to look awful because I'm doing it with my fingertip, but my dot plot points on A, if it has low bias, should be around that arrow compared to B. And then it says A also has lower variability. That means they should be closer to B. So A seems like a great statistic. I don't know how many points I'm plotting here. It said 8, 5, there's 8. So a low bias, meaning I'm around the mean. Low variability, they're pretty close together. And then B, your answers could vary here. But B is not as good. B says it's higher bias, so they're more spread out. We'll just do this. 1, 2, 3, 4, 5, 6, 7. We'll just say 8. So they're more spread than A, because A has lower variability, so B has more variability, and B has more bias if A has lower bias. This is just one of many examples you could have, or correct answers you could have given. But low variability and low bias, like statistic A is described, means it's somewhere around the mean and relatively close together, or around the parameter of interest. I just used a mean as an example. Statistic B has higher bias and it's more variability, so it's missing the target and it's more spread.